Hello, welcome to the video. In this lesson, we're looking at section 3.3, where we're going to look at proofs with parallel lines. So it asks here which of the formulas involving parallel lines and transversals is the converse true. So one of the first theorems that we're going to take a look at is the corresponding angles converse. So if you recall from chapter 2 when we talked about converse, that means we flip the conclusion and hypothesis in our conditional statement. So this theorem has a conditional statement right here that states that if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So if you looked at the corresponding angles theorem, it would say that if two lines are cut by a transversal, um, the line, so that the lines are parallel, then the corresponding angles are congruent. So that, remember, you just flip it. So that's why we have it as the converse. So we can say that if angle 2 is congruent to angle 6, then we can say um, line J is parallel to line K. So that's where we can use this converse to determine if lines are certainly parallel. So in this particular instance, they want to know, they want us to find the value of x that makes m parallel to n. So these two angles by relationship are corresponding. Since they are corresponding, for m and n to be parallel, they must be congruent. So we're going to have to say that 3x plus 5 is going to be set equal to 65. So to find that, we have to do some algebra. So when we subtract 5 from both sides, so I get 3x is equal to 60, and then 60 divided by 3, I get x equals 20. So x would have to be 20 in order for for m to be parallel with n. In this particular example, we have a diagram here where we have this angle here is at 75 degrees and this angle here is at 105 degrees. They want to know, is there enough information in the diagram to conclude that m is parallel to n? The answer is yes. We do have enough information. Reason for that is we know that, I'll change a different color, is this angle here and this angle here is a linear pair. All right, so since they are a linear pair, we could say that, oh, 180 minus 75 is going to be 105. Well, since we found out that those are linear pair and this angle are the same, and those two angles are corresponding angles. So by the corresponding angles converse, we can say that M is parallel to N. In this particular one, they want us to explain why the corresponding angles converse is the converse of the corresponding angles theorem. So here it says, if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. All right. So if we look at the converse, it says if two lines are cut by transversal, so the corresponding angles are congruent, then the lines are parallel. So what I first read was the corresponding angles theorem. All right, course, again, I can write it out. It says if two parallel lines are cut by a transversal, Sorry about that. So as I was writing, it says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So again, that's what the corresponding angles theorem tells us. So that's 3.1. So if if you take a glance at this one, are the conditional statements, are the hypothesis and conclusions flipped? The answer is yes. Yes, they are. So what we can say is, as our explanation is, we replace the conclusion and hypothesis and vice versa. So that is how you can explain why is in fact the converse. So not only do we have a corresponding angles converse, we also have an alternating interior angles converse, an alternating exterior angles converse, and a consecutive interior angles converse. All right. So I encourage you to read those conditional statements and um, and go from there. So what we have here is they're asking you to prove that if two lines are cut by a transversal, so the alternating interior angles are congruent, then the lines are parallel. So right now we're basically trying to show, so since here they've given us, it looks like angle 4 is congruent to angle 5, they want us to prove that line G is parallel to line H. That's what they're asking. So we have statements and we have reasons. Like always, the first thing is what's given. Angle 4 is congruent to angle 5 because it was given to us. So since they said here, so since we can't use the alternating interior angles converse because it was given to us, but what we can do is, um, since we were given angle 1 here, we can say that um, angle 4 is going to be congruent to angle 1 due to vertical angles. And then if you notice, I have angle 4 is congruent to do different angles, so I can now say that angle 5 is congruent to angle 1 due to the transitive property. And since we know that 1 and 5 are congruent, now we can use another converse, which means that G is in fact parallel to H because of the corresponding angles converse. In this one here, it says in the diagram, R is parallel to S and angle 1 is congruent to angle 3. They're asking you to prove that line P is congruent to line Q. So got our statements and we got our reasons. So first off, we can just write, okay, R is parallel to S. We can say that angle 1 is congruent to 3. That is given. And I'm just going to write in hash marks because they gave it to us. Second, what I'm going to look at is we have 1 and 2 are both part of uh, lines R and S. And since R and S are in fact parallel, we can say that angle 1 is congruent to angle 2 because of corresponding angles. All right, so now that those are congruent, now we notice, oh, angle 1 is congruent to 2 different angles. So now I can say that angle 2 is congruent to angle 3 because of the transitive property. And not only are they congruent because of the transitive property, they also are, in fact, alternating interior angles with respects to line P and line Q. So now I can say that P is parallel to Q because of the alternating interior angles converse. Last theorem that we have in this section that we're going to take a look at is called the transitive property of parallel lines. So kind of the same idea. If you have one pair of lines that are parallel and you have another set of lines that are parallel, but they share a common line, which in this case is like line Q, then the other two lines are going to be parallel, so P is parallel to R. With that being said, using that transitive property theorem, this particular one says the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. So to write this as like a proof or to make it as a statement, you can say, because of this statement here, you can say, well, S1 is parallel to S2 because it's immediately on the bottom. Then you could say that S2 is parallel to S3. Well, we share a common, so now I can say that S1 is parallel to S3. And you can kind of, what you're gonna eventually do is just keep going with that, and then you're gonna say, okay, well, S3 is parallel to S4, well, because, oh, look, they share that transitive property of parallel lines. Now I can say that S1 is parallel to S4. So now I can go, oh, S4 is going to be parallel to S5, and so on and so forth. So you're just going to go all the way down and write in, all right, well, because move all the way down, so it'll say something like S1 will then be parallel to S13. So that's how you can say that the top one is going to be parallel to the um, bottom stripe. And I can make the list, and if you really want me to, please leave a comment below. I'll show you what exactly that all entails. But that is how we find proofs with parallel lines. Hope this helps. Until next time.